So let's talk then about these image level backups, this real differentiator for why we select a Veeam over a traditional file and folder based solution. Veeam, as you know, produces image level backups, and I have here primarily in parentheses because Veeam also includes an agent, which we'll talk a little bit about here, but most of what Veeam intends to produce are image level backups of VMs. These image level backups are essentially the virtual machine disk file that corresponds with the VM. And so, that being the disk itself, enables us to treat our virtual machine as an object rather than that collection of files and folders. It also allows us to back up those virtual machines at the block level with the aid of virtual machine snapshots. A lot of the secret sauce in terms of what we're actually doing under the covers comes not so much from Veeam itself, but rather from the snapshotting functionality that your hypervisor provides. These snapshots have been around since the beginning of hypervisors, and so this is a very mature technology for enabling one to capture what would otherwise be a very dynamic file system in a single fell swoop. Now, one of the major tenets here of any image level backup is that the very first backup in any job always produces a full backup. We have to have some starting point for this virtual machine that we can use. But once we have that starting point, it's this whole concept of changed block tracking that allows then our subsequent backup jobs to be incremental. Only those blocks that are then changed are captured by subsequent backup jobs. This is a great idea because creating a full backup job takes a lot more resources than just figuring out what's changed since the last full backup job. This process also facilitates the restore as well, enabling us to quickly then restore the virtual machine back using that same block level technology. If I need to restore an entire virtual machine, I have the one or a couple of virtual disk files that need to go back in the proper location. Now, this is great, again, if I need to restore that entire virtual machine, I just have one disk. But what I do pay is a little bit of extra effort to index and understand where all the files and folders are on that virtual disk if I ever need to restore an individual file, a folder, or an application. And so one of the things we'll be talking about here as we explore the different approaches is in prioritizing what makes most sense for each particular backup job. Is it more important for you to back up the job quickly, or is it more important for you to restore the job quickly? Different approaches, among other things, have different priorities for optimizing the backup versus optimizing the restore. Now, a bit later on, as we start configuring then these jobs, I want to talk here about the exact series of steps that occurs when we do then kick off that job. Let me then walk through exactly what occurs here. So let's say a new backup job session starts. One of the first things that happens is that Veeam Backup and Replication then starts the Veeam Backup Manager process there on the backup server. That Veeam Backup Manager process is going to read whatever settings are associated with that job from the configuration database on that server and then create a list of virtual machines and their tasks that need to be processed. For every virtual machine and every disk added to the job, then Veeam is going to create a new task. Once those tasks are created, Backup Manager is going to connect to the Veeam Backup service, which is going to perform some resource scheduling there to manage all the tasks and resources that are currently going on in the backup infrastructure. You'll find as the number of jobs you create increases that managing when those jobs actually occur becomes some of the challenge in just the simple administration of Veeam. This resource scheduler is going to check whatever infrastructure resources are available and then assign backup proxies and repositories to process those job tasks. Earlier, we talked about the configuration of an automatic selection for a backup process or a backup repository, and then also sometimes limiting it so it only occurs there in the local site. It's these automatic configurations with some limitations that ensure that the Veeam process here, the resource scheduling process, can use the most available resources for each job as the time comes. Once that scheduling is then completed, Backup Manager will connect to the Veeam transport services on the target repository and the target backup proxy. Once connected, a Veeam data mover process is initiated for each task that the proxy is processing so that the rules for that data transfer, like your network traffic throttling rules and so on, can be sent to both data movers, there on the target side and here on the source side. Now, once those instructions have been sent to those data movers, the two data movers on both the backup proxy and backup repository will then establish a connection with each other then for the data transfer. The Backup Manager then queries for information about which virtual machines are on which hosts in the virtual infrastructure. They're using the Veeam broker service that exists inside of your vCenter, your Hyper-V environment. These steps here set the stage for actually beginning then the backup process, but there's still some activities that are required inside the virtual machine. If you've enabled either of the quiescence options, this application-aware image processing on the job, it's exactly here where that guest interaction proxy comes into focus. That proxy will connect to the OS inside the virtual machine and inject that runtime process on that operating system to perform whatever in-guest processing tasks are required. We talked earlier about that guest interaction proxy and how this process is injected on that virtual machine without requiring the installation of a permanent agent. The runtime process then performs its in-guest processing tasks, which enables a snapshot to then be created for that virtual machine by vCenter, in the case of Hyper-V by your Hyper-V host. That snapshot then puts the VM's disks into a read-only state, and then begins processing any changes from that point on into the snapshot file. And so what we now have is a read-only copy of a point in time of that virtual machine's state. Any changes that are going on in the virtual machine, just like a regular snapshot there in your hypervisor, are going to be written to the snapshot file itself. It is now using that read-only copy of the virtual machine's disk that the data movers can begin transferring the data from its location there on disk into the backup repository using any of the transport modes you've configured. If this is an incremental job, Veeam will attempt to use change block tracking to retrieve only those data blocks that have been changed since the last session. But in some cases, when change block tracking is not available, the data mover on the target side can interact back with the backup repository to get the backup metadata and figure out which blocks have actually changed. Regardless of how this is configured, once the VM data starts being transferred, the source data mover is going to perform some additional processing, like zeroing out data blocks, blocks of swap files, or any OS files that you have specifically excluded from the backup. There's also some compression that's involved, as well as encryption that's involved if you've enabled it there on the job, as that data is then transported to the target data mover there associated with your repository. This process continues as the backup completes, and once that backup finally does complete, then Veeam will then contact your hypervisor host or management infrastructure to then commit that virtual machine snapshot and return the virtual machine back to its original configuration. This removes the snapshot's Delta file and returns that virtual machine back to no longer having that snapshot file associated. Any changes to files and folders on that virtual machine that occurred during the process of the backup are then rolled back into the main virtual disk file there in preparation for the next backup whenever it should occur. And so that actual process then of capturing all this data and transporting it over to our repository server will be done using one of three different behaviors, which we'll talk about here next. These are the forever forward incremental, and reverse incremental configurations.